Today's vodcast, V43, begins on slide 66 and goes through slide 82. It's about direct and indirect relationships in tables and graphs. So there are two ways to determine if a relationship is proportional. It depends if you're looking at a table or a graph. So if you're looking at a table, all the ratios of numbers in the table have to be equivalent. And if they are, then the relationship is proportional. And these ratios we're going to think of as unit rates, and you're going to see why in our first example on the next slide. So that's if you have a table. If you have a graph, you need two things to occur. You need it to form a straight line, and it needs to go through the origin, or the point 0, 0. And if it does, then the relationship is proportional. So here's our first example. On a field trip, every chaperone is assigned 12 students. And we want to know if the student to chaperone ratio is proportional. So here's the table, and here are our ratios. Now you're going to need to add a few things in for me. First, let's put an X by the chaperones and a Y by the students. And we're going to think of this as a unit rate for students per chaperone. So our X is the chaperones and our Y is the students. Now this isn't in your slides, so write that in too. So students per chaperone can also look like this, students over chaperones. Or, because we labeled students Y and chaperones X, Y over X. So the unit rate for each group of Y and X has to be the same in order for the relationship to be proportional. So let's take a look. 12 divided by 1 is 12. 24 divided by 2 is 12. 36 divided by 3 is 12. 48 divided by 4 is 12. 60 divided by 5 is 12. So this table is proportional. Let's take a look at this example. This is about a pizza place that has a plain pie for $10 and each topping costs $1.50. So we want to know if the cost of the pizza is proportional to the number of toppings. So our cost is Y and our toppings are X. So the cost per topping is what we're looking for, the unit rate, which is Y over X, or cost over topping. So let's set that up. 1150 over 1, 13 over 2, 1450 over 3, 16 over 4. 1150 divided by 1 is 1150. 13 divided by 2 is 650. Now, I automatically know that this is not proportional because these ratios aren't equivalent. But let's keep going anyway. 1450 divided by 3 is 483, and 16 divided by 4 is 4. So this is not a proportional relationship. The unit rate is not the same. Here's another example. We have year and we have income. Year is our X and income is our Y. So Y over X, or income over year, meaning income per year, is as follows for the chart. 22,000 divided by 1, 44,000 divided by 2, 88,000 divided by 4, and 110,000 divided by 5. If you divide all of those to find the unit rate, you get $22,000 for everything. So yes, this table is proportional. Let's take a look at one more because it's a little different. So here we have our X and our Y, just like we've been writing in. Only this time we don't have any labels, but that's fine because we still know it should be Y divided by X. So if we take our Y columns and divide by X, we have 7 over 2, 17.5 over 5, 21 over 6, and 34.5 over 9. When we divide them, we get 3.5, 3.5, 3.5, but then we get 3.83, and that's why you need to test all of them. So since all the unit rates are not the same, the relationship is not proportional. Please pause the video and try slide 72 on your own. Please skip slides 73 and 74. This slide is a reminder we had it at the beginning. We already did tables, but now we're moving on to graphs. So remember, the graph has to form a straight line and it has to go through the origin to make the relationship proportional. This is the same table that we saw before, but now it's graphed. So we have students per chaperone, and this time we graphed the points. Now if you notice, chaperones was our X and students was our Y. That's still the case because when we go to graph it, chaperones are on the x-axis and students are on the y-axis. So we go over 1 up 12, over 2 up 24, over 3 up 36, and so on. Now remember, we're looking for a straight line that goes through the origin. So we definitely have a straight line. All the connected points form a straight line, and it does, in fact, go through the origin. So yes, it is proportional, and again, we knew that because we had already worked with this table, but now we can see that in graph form. Now this example wants us to make our own graph. So they gave us a table with x and y values, and we need to plot it. So x is the horizontal, and y is the vertical. So we go over 1 up 5.5, we get right there, over 2 up 7, over 3 up 8.5, and over 4 up 10. Now again, we're looking for two things. We are looking for a straight line that goes through the origin. So this line, although it doesn't look like it, should be straight. When you go to draw your graph, please use a ruler. I can't on the computer. But if you connect all the dots, it's definitely a straight line. However, it does not go through the origin. Again, the origin is 0, 0. And if you notice, this line will keep going, but it will hit into the y-axis before it gets down here. So since it does not go through the origin, it is not proportional. Please try slide 78 on your own. And instead of just circling yes or no, please write straight line and goes through origin and answer both of these questions with either a yes or no. If you get 2 yeses, it's a yes. If it's one of each, it's a no. Or if it's 2 no's, it's also no. You are going to skip the rest of the responder questions and save them for class. Please write skip the rest of the responder questions on your slide, and you are done with V43.